Back again, this time bringing you a lesson on the Pythagorean Theorem, which was discovered by none other than the Greek man himself, Pythagoras. And I think it's important we reflect for a minute on the legacy this man left behind him. I want to direct your attention to guitars. And we know guitars make sounds today based on string length and string thickness. And that's what he discovered. And so his discovery led to the invention of things like harps and pianos and guitars. But he didn't stop there. He messed around with pipes. He took pipes, blew in them, put holes in them, and realized you can create sounds that way too, which gave rise to musical instruments like trombones and trumpets and flutes. Fill cups with water and strike them with a metal spoon. You create sounds that way, or maybe bells. Different sized bells create different sounds. Well, all this was based on the work of Pythagoras. But that's not what we're learning today. We're not going to be looking at his musical impact. We're going to be looking at what he did with squares and triangles. And before we do that, it's important to refresh our memory with the last lesson. Because we looked at squares in the last lesson, and then we asked ourselves, look, if you're given the area of a square, how do you calculate the length of the side? And we said you just square root. Square root it, you get 7. Because 7 times 7, base times height, makes the 49, which is the area of the square. But what do you do if you get like square root of c squared? What do you do then? Well, you just say c, because c times c is c squared. What about the square root of f squared? Is f, because f times f is f squared, right? So that's important to review. Now the new stuff. If you're given a triangle like this, and then you see a box, just a little corner here, a box, that stands for a right angle. That makes this triangle a right angle triangle. So go ahead, write right angle triangle. Right angle triangle. That's the only triangles that we're going to be looking at today, the right angle ones. Now we have to learn how to label it. Because if you go here, now listen, watch this. Start at the right angle and go opposite. Opposite the right angle. You get a side here. And that side is called the hypotenuse. Hypotenuse. And it's labeled C. But Mr. Mellon, why don't they label it H for hypotenuse? That's a good question. They just picked the letter C, I guess, for simplicity. And so that has to be labeled C. It's not an option. Don't change the letter right now. Just call it C. And then the other two edges have to be A and B, and we call them legs. So every right angle triangle has 2 legs, just like you. You have 2 legs. One has to be A, one has to be B. You can flip the order of A and B. You can call this one B and this one A. It makes no difference. But one has to be one A and one has to be a B. Write this down. The hypotenuse has to be the longest side. It's always the longest side. And it cuts across like that. Now here's what Pythagoras did. He sat down one day and he took a square. Then he took another square. And he joined them at the corner. And then he's like, well, I can get a third square, hook it diagonally, and oh, I get a triangle. Now that's not that impressive because a lot of you have figured that out before the age of 3 playing with blocks in your basement. But he did something different. He figured the area out of this square and figured the area out of the little square. And then he's like, that third square has an area. Oh, 16 plus 9 makes 25. That's pretty cool, but does it work every time? And he tried it with different sized squares with different areas, and guess what? Yup, it worked every time. Every single time this was true. But then he's like, okay, if I add the squares that are hooked onto the legs of the triangle, right? Remember, these are the legs and this is the hypotenuse. It only works if I add the legs to get that third one. So you know what he did? He came up with letters and he's like, okay, I'm going to call this A and I'm going to call this leg B and I'm going to call this edge leg C. And then he's like, okay, how do I turn leg A into the area of that square? That's not hard. You just go base times height. You go A squared. But then you got to take the other leg and you go B squared. And you add them together. So if you go A, let's say this is 4. I guess it is 4. 4 times 4 makes the 16. And this one's going to be B times B, which is going to be, I guess in this case, 3 times 3. And then guess what you get? You get the area of the third one, which is going to be C squared. Right. So it's going to be 5 times 5 is 25. So that's C times C, C squared. And he came up with this formula and he said, haha, this works every time. Use it whenever you need to. So when will we ever need to? We're going to see some examples in a moment. Now some terms. Write the Pythagorean formula. That's easy. You just go A squared plus B squared equals C squared. What kind of triangles can you use the Pythagorean theorem on? The right angle triangles. Write it down, right? Right angle triangles. Pretty simple, hey? How do you find the hypotenuse? How do you find this? You go opposite the right angle. Find the right angle and go opposite. So write opposite the right angle. Let's do it on the bottom ones here. It says label A, B, and C on these triangles. Okay, well, let's label C. I recommend labeling C first. Right angle, opposite, C. A and B. If you put this B and this A, it's still right. Right angle here, it's hiding. It's right there. Go opposite. That's C. So one has to be A, one has to be B. Here, it's upside down. Go opposite. C, A, B. Right angle, opposite. C, A and B. Oh, wait. There's no right angle here. Ah, okay, because you can't do it, we X it out. There has to be a right angle, otherwise this formula doesn't work. Oh, look, we have a right angle triangle. So let's write the formula. Let's write A squared plus B squared equals C squared. And look at the sides now. Which side is A and which side is B and which side is C? Well, this side is C, so we'll leave it alone for now. This can be A and this can be B. So substitute. Go 9 square for A, go 12 square for B, and then add them. And then just write C square here. Now look, if you go 9 square, you know what happens? That means you're going 9 times 9. You're building a square. You get 81. Okay, we'll write 81. And what happens if you go 12 square? That just means you're going to go 12 times 12. You get 144. Then you add them. What happens if you get 81 plus 144? You get C squared. Don't add them yet. Keep the left side separate from the right. Keep them separate. Keep the sides separate. You add these now, you get 225 equals C squared. But look, I add these, I get C squared. But I don't want C squared. I want C, which is the edge of the square. How do you turn an area into the... Yes, square root it. So square root C squared, you get C. Square root 225, you get 15. So this has to be 15. The hypotenuse is 15 meters. You go ahead, you try this. You could pause the video. I'm going to go on with the answer, assuming you've done all that. You write A squared, B squared equals C squared. We're adding them. Now we'll plug in the pit. So let's label the sides. Always label your sides, boys and girls. A, B, here's my right angle. Bang, C. I don't know C. That's no problem. Just plug in your A. So A is going to go here. That's 4 squared. 3 squared equals C squared. Keep your C's lined up. This is going to make 16. This is going to make 9. And it's so tempting to just write 25. But don't do it. Keep your left side separate from your right side. Write C squared. Now solve this. You're going to get 25. And then the last step, you're going to square root the 25 because we don't care about the area. We just want to get the edge of the square. And then square root that. Look, you're going to get c equals 5. That is 5. And look, it's the longest side, so it works. This is a little bit more challenging, but not too hard. Look, we're going to, okay, it's a right angle. That's C. So this can be, let's say, B, and this could be A. Write your formula. Now substitute. We don't know A. We know B, 12 squared, and we know C. 15 is C to the power of 2. Now this here, let's substitute these values. Let's figure them out. This is 225. And this here is going to be 144. And this is a plus sign, and that's a squared. Pretty good? Remember algebra? Let's use it. Minus 144. Remember, isolate the variable. Minus 144. That's going to make 81. And that's going to make 0. This is gone. And then I get a squared. But I don't want a squared. I want a. Okay, no problem. We'll just square root a squared. And that gets us a. And square root 81. And it gets you 9. A equals 9. Beautiful. Yes. 15 is still the longest side. So it's a reasonable answer. You try this one. And I know some of you are like, Mr. Malamat, can I try this one? It's a rectangle. You said it's only for right angled triangles. Okay. Don't let the rectangle fool you. You've all cut sandwiches before and turned them into triangles. Toast is a rectangle or a square. You cut it. You turn it into a triangle. And look, you have a right angle. It's right there. It's right there. So figure it out. Okay. You've unpaused the video. Let's look at the answer. Did you do this first? Way to go. Did you label your sides? That's C. So this can be A and B. Did you do this? Way to go. Let's keep going. Substitute. C is going to be here, C squared. This here is 144 plus 36. Oh, that makes C squared. Now keep your left side separate. 144 plus 36 is going to be, let's see, 54, 64, 74, 180. But I don't want C squared. I want C. Don't be sad. Square root. Square root. The square root of 180. Okay, I need a calculator for this because it's not a square number. Punching it in, I get 13.4. Equals, and square root of C squared is C. So C has to be 1 or 13.4 meters. Is it the longest side? Uh-huh. Last one. Here, I want you to figure out the entire base. I'm giving you the height of the triangle, and I'm giving you the edge length here. But Mr. Melham, you said it's only for right angle triangles. There's no right angle here. Yes, there is. It's right there. It's actually 2 triangles in one. Label your C. A and B. There, I started it for you. Go ahead, finish the rest. Okay, you paused the video, you unpaused it. Let's go ahead and do this. A squared. Yeah, B squared equals C squared. That's step 1. Now substitute. C is 10. So I'm going to write 10 squared. B, I don't know B, so I'll just write B squared. Plus sign, and A is going to be 8. That's your setup. 64. B squared, I don't know B, just write B squared, and that's 100. Oh yes, now it looks like a one-step equation with the algebra unit that we did. Minus 64. Minus 64. Make your equals bar. This is 0. B squared. Look at this, baby. Look at this. This is going to make, what is this? 36. Oh, beautiful thing. Square root B squared. Oh, yes. Square root 36. You get B equals 6. Put that 6 there. That's got to be our answer, right, Mr. Melman? I did all the work. I got 6. Oh, but you forgot something. I want the entire base. I don't want just from here to there. Yeah, you got it. You got to double it. That's going to be 6 as well. You get 12. It's going to be 12 meters. That almost takes us to the end. Some key ideas. The hypotenuse is located opposite the right angle. Okay, and it's the longest side of the triangle. So remember that. Got to go over a couple more things though. The Pythagorean Theorem allows us to calculate the hypotenuse. Okay, that's what the whole purpose of this is. The formula is right here. And I think maybe the most important part is you can only use it on right angled triangles. And that pretty much sums up this lesson, ladies and gentlemen. I'm pushing almost 17 minutes. 17 minutes that was worth every second of your time. And I just want to say thank you and have a great day. Can't wait to see you next lesson. Take care. Bye-bye.